Okay, problem number 16. We have this function here, square root of 3x squared plus x plus 10, all that over 2x minus 5. It asks us to find horizontal asymptotes of h. How do we find horizontal asymptotes? Really what this is asking us to do is to calculate the limit as x goes to infinity of the function and the limit as x goes to negative infinity of the function. And if either of these ends up being a constant that is not infinity, then we get asymptotes here. So yeah, this is just a good thing to know. When you see horizontal asymptotes, this is what you should be thinking about. You should immediately jump to thinking about these limits. Okay, how do we do this? I'm going to in this first one, divide both top and bottom by x. So when we move the x inside the square root, really we're going to be dividing by x squared, the square root of x squared. So what do we end up with here? Limit as x goes to infinity of, so downstairs it's 2 over x minus 5. And upstairs, again, we divide what's under the square root by x squared. 3x squared over x squared is 3, plus x over x squared is 1 over x, plus 10 over x squared. And so at this point then, we can say, okay, as x goes to infinity, we get 3 plus 1 over infinity, that's going to 0, plus 10 over x squared, that's going to, as x goes to infinity, that's also going to go to 0. And downstairs, the 2 over x, that will go to 0, and the negative 5 is our constant. And so what happens here, upstairs is square root 3, downstairs is negative 5. So yes, we have our first horizontal asymptote here at y is equal to square root 3, negative square root 3 over 5. Okay, so for the second one, it's going to be similar, but because x is going off to negative infinity, we have to be a little bit more careful when dealing with the square root. Because the thing to remember here is that the square root of x squared is not, we don't just say it's equal to x, we say it's equal to the absolute value of x. And so in this case, if x is negative, which is if x is going to negative infinity, the square root of x squared is actually equal to negative x. This might feel a little bit weird to you, but let's just plug in a number to make you realize what's going on. If we plug in x is equal to negative 4, so if x is equal to negative 4, this says that the square root of negative 4 squared is equal to negative 4. But negative 4, that's 4. And this is the square root of negative 4 squared is 16. And this is also 4. So if x is negative, square root of x squared is equal to negative x. What consequence does that have for this problem? Well, let's factor, I'm going to approach it just a little bit differently than I did before to show a variety of methods for doing these problems. I'm going to factor on x squared from under the square root. So the thing under the square root is going to be x squared times 3 plus 1 over x plus 10 over x squared. And so then, when we take the square root of x squared, we get negative x. And now we divide both top and bottom by x. And so what do we end up with here? This is the limit as x goes to negative infinity of the negative of the square root of 3 plus 1 over x plus 10 over x squared. All of that over 2 over x minus 5. So once again, as x goes to negative infinity, 3 is 3, 1 over x goes to 0, 10 over x squared also goes to 0, 2 over x goes to 0. And we are just left with now negative square root of 3 over negative 5, so square root of 3 over 5. So we actually have a second asymptote here, y is equal to positive square root 3 over 5. So this is a little bit of a tricky process here, understanding what's going on with the square roots to make sure you find both asymptotes.